In this video, we will talk about eye gaze detector. This is another sensor to detect humans' eye gaze or eye trackers, right. So how does eye trackers work and how it is detecting our eye gaze. So please check this blog and in detail, right. So let me show the blog. Again, the blog is from iMotions, because I mentioned that iMotions is a company which integrates different sensors, and they created a core engine which combines the data from different sensors to provide you the combined one single system, so that you can do analysis better. So eye gaze is detected using detecting your eye, people, and the reflection of where some light or some reflection happens, right. That direction is used to say which direction you are looking at, and your distance from the screen, if you are watching a laptop, that's distance from the screen is used to say are you looking at which place and what are the location you are looking at, and that is how the eye trackers work. So read this blog, it is interesting. And the typical eye tracker in a portable eye tracker is this. This is a simple eye tracker, Tobii Eye is the company, is the leader in eye tracking devices. It is a typical eye tracker, small device which can be attached to your laptop, laptop screen, and then you can start collecting the data. And what happens, there is more other eye trackers, like you can wearable eye trackers in the glass, you can put those eye trackers. These are a bit old. I will show the latest ones from Tobii Eye. So what happens is the eye tracking data collects the participants' eye gaze data. These are the products by Tobii Eye. Tobii is the company which is pioneer in this field, and they make eye trackers devices. The latest one is Tobii Pro glasses. There is no need to have extra some device, or you have to focus on this, everything is gone. Now based on this, the new technology, they are able to detect eye gaze even you are interacting with the object, you are looking at some product or something like that. And this is the Tobii Eye Pro, the research level eye tracker. Also something called Tobii Eye Nano, this is a small, and that can be used for the research also. And they have more devices, the one Tobii Eye also had one device, called Tobii Eye 4C. Tobii Eye 4C is developed especially for the gaming purpose. It is very low cost, in the sense it is for the level of technology they use, they do not get much. The Tobii Eye 4C is around say $100, or in India you can get in Amazon after import and everything, you just get it for 13 to 15,000 rupees. So in a research, it's really it's very easy, and you can collect say 10 eye trackers and you can collect data. But the purpose of Tobii Eye 4C is for gaming, so you cannot use Tobii Eye 4C for research purpose. That is, the declaration says that you cannot copy data or analyze data from the 4C. So yeah, beware, do not use 4C. If you are using 4C, talk to Tobii Eye company and get the license permission. Again, you have to pay huge money for getting license. So for research purpose, there you have Tobii Eye Pro Fusion or Tobii Eye XR120 kind of devices, or Tobii Eye Nano is 60Hz eye tracker, that is really good, and that is not really costly. It might cost 2 to 3 lakhs. So that it is easy for people to start buying and making some research out of it, do collect data and create some research proposal. So Tobii Eye tracker, so is talking about collects data at a particular frequency. So let us see. There are other eye trackers which is not based on external device, just based on the webcam. Commercial ones such as Tobii Eye Sticky, Tobii Eye is also giving things called Sticky, it is webcam based detector, anybody can use it. And other one is called Real Eye. Real Eye is a very interesting one. Let us see what is Real Eye. So Real Eye is a screen based webcam eye tracking, you can give a try, try it for free, just launch demo, and actually detects the where the student is looking at based on the emotions, and after that it gives the analysis of data. It is not just detection also. It's not much costly compared to TOBI for the research purpose, but there is one more is from the Brown University. It's called a web gazer. It is also free, it's open source, so use it. The challenge is when you test all of them, it needs a proper lighting. It's that when students is interacting with the computer, laptop, its lighting should be in our face so that we can detect the light from the screen, and the pupil direction has to be detected to detect where on the screen the student is looking at it, and it's very sensitive. It's you can't detect, if I look at a particular page, suppose looking at the W, it will not be correct. No, it's not so accurate like a TOBI detectors, like the screen, the external eye trackers. The reason is webcam is on top. For example, if you are looking at a laptop, your webcam is on the top. If I am reading the bottom of the page, my eyelids are kind of closed, I am reading, so the webcam may not be able to detect. So why I would say that go ahead and try reali.io demo and start looking at the bottom side of this page. You will see the accuracy is not so correct. But if you are conducting a research where the area of interest is large, this webcam based eye trackers will be beneficial. The reason is buying a research grade eye tracker from TOBI and conducting a study in a real classroom for 30 students is not possible, even if you have a lot of money. So when I say AOI, suppose this is my screen, the computer based learning on the screen, and maybe this is the menu, and there is a big picture, and there is some text. In your research, if your area of interest is very big, such as you want to capture how much time a student spent on menu, how much time a student is looking at picture, how much time a student is looking at text, that is the thing. And by using this information you want to understand students learning, then this is perfect. This webcam based detector might work for you. So check it out. I won't suggest you to go for real eye or web gazer. Works pretty much same compared to real eye, just how to integrate it and collect data on it. Okay. And some of the feature extraction, the analysis is not really tough, it's easy. I will show how to do that. So there are two features key in a eye gaze detector. The one is called fixation, the other one is called saccade. Fixation is your eye is fixating on a particular point, and how much time you have to fixate, and what is that point, is it a single point or some square bracket, it depends on your research question or the way you want to decide your duration and the bracket. For example, if I am fixating on this particular moment, this is the one part, if I am fixating on here, and I would say anywhere my fixation, I am looking at my eyes is looking at anywhere in this box for more than say 50 millisecond or more than say 100 millisecond, I call it as a fixation. This is a fixation. So when you are reading something, actually you are fixating from point to point. So you fixate here, then you fixate here, then you fixate here, then you might fixate here, something like that. The moment between the fixation, right, is called saccade. So the transition between fixation is called saccade. That is the two key features in the eye gaze detector. Okay. So you get a raw data from eye gaze eye detectors. So raw data looks like this, timestamp and the XY positions. Let me okay. So raw data looks like this, just a timestamp and the XY position. So what is XY position? For example, in your screen, consider this is 0 0. If your screen size is 900 cross 600 or something, then this will be the 600, 900, something like that. Sorry, this is 900 dot 600 because x is 900, so something like that. Or you can change where to start 0 0, or how it works is basically it takes a central, this is actually a 0 0. From here it actually takes the coordinate value, and the eye tracker might give you the values in this kind of this kind of values 0 0, you can convert it based on the way you want it. So the raw data looks like this, the timestamp, the x position, y position, timestamp, x position, y position, that is the exact raw data. If you want the orientation like your eye head movement also, it can be added because it is a point of reference from where you are looking at it. So also the important thing is sample rate. I mentioned in some slides above that there is a sample rate 60 Hz or 90 Hz. There are Tobii Nano, it says 60 Hz. What is 60 Hz means? They collect 60 samples per second, which means at every 15 milliseconds you will have XY position, right. So the eye gaze is so accurate, and in a research, in a reading kind of research, the sample rate is around 1300 Hz. That is the really recommended version. High rate translation rate, because are you looking at which word, are you looking at which letter, such a kind of analysis. But I would say 90 Hz to 120 Hz or 60 Hz is better, do not go for a high end kind of sample rate. If you use a webcam based eye tracker, that is the webcam based eye tracker, the sample rate will be 25 Hz, right, it is not much. So you have to make sure that is also issue there. Okay. So I will say what is fixation and sucker. This is a picture from Wikimedia, the Creative Commons license. So this person actually fixated on this particular location here first, then he fixated at the face, then he fixated here, then fixated here, fixated here, then fixated here, then fixated at the first here is in 0, sorry, not in the first place. So this is how the fixation movement happened, and the line 1, 2, 3, 4 indicates the sequence, and this line is a saccade, that is a fixation. Also there is this kind of eye trackers give you other kind of information, that is called heat map. Heat map in the general meaning heat map, that after you look at this particular Wikimedia page, after 5 minutes where you spend more time fixating. It is not talking about sequence or saccades, instead it is giving where you focus more. This is the more focused area, these are lightly focused, this area were not actually looked at all. So this is very helpful if you make advertisements or some marketing some product, where is this participants, where is this customers are looking at. So that is what very useful for marketing areas. But we can use this eye tracking data also for the learning analytics, that is the whole idea of this. Okay. So I said we can use eye trackers for the learning analytics. How can we use that for learning analytics? So write down your answers, after that resume the video to continue. So you can detect learners cognition, whether they understood things or not, or the reading skills, are they focused, attention, engagement, the performance, lot of things can be detected from the eye tracking data. I will show one example. So in this paper we predicting learning by analyzing eye gaze data of reading behavior from EDM 2018 paper. In this paper they used a system called Betty's brain open ended learning environment. What is Betty's brain? I will just give a very brief about Betty's brain. If you are interested, go and check the page called Betty's brain from Vanderbilt University by Professor Gautam Biswas. They have all those Betty's brain system in a web is there. Betty's brain, as this is the agent Betty. The student's role is to teach this particular agent to solve a particular problem. Okay, this Betty. Initially Betty's brain is plain, there is nothing in it. Okay, and you can ask your teacher, there is a master Mr. Davis, you can ask him whether if you need any help with that. But your goal is to teach Betty, go and do that. So in order to teach, you have to understand some climate change or some science concepts. So all the reading materials is given here, and there is a content. A student has to read it, and they can take notes, and after taking notes or after reading it, their goal is to go and create a concept map. This space is called Betty's brain. Initially it will be empty, then you have to create a concept map. This is a concept and this is in a relation between these two concepts, the causal relationship, and it increases, decreases. If deforestation increases, vegetation will reduce, decrease. And this marking red and all is you can mark, it is not the system marking it right or wrong. You can tick mark it as a correct, or you can tick mark it as I do not know, something like that. This marking is also based on your taking the quiz, and based on the answers you can think of it. Then you can ask Betty, after you create the map, you can ask Betty to take an exam. When the Betty takes exam, you can take exam on multiple sections or whole chapter or multiple subsections, and when the answers are correct it is marked here, and if you select it, which particular path is used to answer this particular question is given here. So, you know that these two path is correct, so then you can mark them in a green mark. That is how the student marked here. So, the idea is that a student is teaching Betty to do something. When the student is not able to do that, it is not the student is failing, the Betty is failing. Okay, that is how the feeling goes on, the emotion is actually changed. So, this is a Betty's brain. In this system we have area of interest in each text. Okay, I am just going to put the same title here because it is going to be hiding it. So, when a student is reading a particular line, when this heat is reflected back to the earth, it is reabsorbed by the earth's surface and becomes absorbed heat energy. So, there are two concepts involved, heat reflected to back earth and absorbed heat energy. Okay, there are two concepts and there is a relationship. If there is a more heat reflected back to earth, there will be more absorbed heat energy. Okay, that is how two concepts relations. Consider I am creating relationship between these two, and this heat reflected to earth and absorbed heat energy. If it increases, absorbed heat energy also will increase. This is the causal relationship between these two concepts. So, what I did, I took the science book and I marked each and every sentence here in this whole chapter, like some 7-8 pages. I marked everything mapped to a particular concept, particular concepts and particular causal relationships. There are only 25 in it. So, I mapped it. Then I created a AOI. My AOI is not very minute, but not very big also. So, my AOI is this, something like this, or my AOI will be like this. So, whenever a student is looking at this page, and if the student looks at this particular AOI, and if he converts his knowledge to concept map, he makes the map correctly, I would say that the student understood what he is reading. If the student spent a year still is not able to convert that into a correct causal relationship, then the student did not understand here. So, using this data we created a simple classifier, and we use the features from the eye gaze data like a fixation count on the AOI, average fixation on that particular AOI, and the saccade angles, saccade amplitude, kind of more extended features from the fixation and saccade only. By using this by using this eye gaze features from the eye trackers on the exact AOI and the corresponding concept map or corresponding relation between two concepts, we label them and we try to predict the students ability to make the concept correct just by the eye gaze information. So, eye gaze data and read actions and performance on subsequent edit action are used to label data to train the validate classifiers. This is the simple idea that we label data, we use tenfold class validation, train plus prediction, and unlabeled data is given to the learn classifier, the classified pages are read. Then we used to linear regression to model the students ability to classify the information, whether they are able to pass it or they are able to create concept map correctly or not, just based on the eye gaze data. And we got a good accuracy, say 80%, but Kogan's kappa is really good. It indicates that just by looking at students fixation and saccades on particular AOI, we can tell whether the student understood the concept or not at 80% accurately. That is what this whole exercise is about. So, what I am saying is, if you use eye tracker, webcam based eye tracker or any eye tracker, and you can actually predict where the student is learning. Is the student learning, is he learning, really learning, is just simply reading, is reading is converted to a knowledge or not. These kind of information can be obtained and can be predicted easily using the eye trackers. So, yeah, in this slide we saw what is eye gaze detection and why eye trackers is used in LA, and I also give one example. In this week we saw that I try to motivate you, there will be data not just from log data or the human observers. We can have a data about the students' facial expressions, data can be collected from different sensors like eye gaze detector or GSR, other data, and we can combine this data to provide complete model of the learner, like a holistic approach. The challenge in multimodal learning analytics is combining data and providing the useful information to students. That is still a challenge, and a lot of people are working on that. And I hope I motivated you on a field called multimodal learning analytics. As I mentioned, this is not a one week lecture. It needs almost half a semester course to teach multimodal learning analytics and play with the data. So, thank you. In the next week, that is the final week, we will talk not any topics, like we will talk about next steps in learning analytics. Thank you.